Now, what exactly is a matrix? A matrix is simply an array of numbers organized into rows and columns. And first, let's talk about the order of a matrix. So consider matrix A, and let's say it has the numbers 2, 7, -4, 6, 3, and 5. What is the order of this matrix? Now, this matrix has 2 rows and 3 columns. Now, the rows are horizontal, so this is the first row and this is the second row. The columns are vertical. This is the first column, second, third. So there's 2 rows and 3 columns. So this is considered a 2 by 3 matrix. The order of the matrix lists the rows first and then the number of columns. Now, you need to be able to identify a specific element in a matrix. For example, what is element 2, 3? Or sometimes it can be written as just element A23. So this is in matrix A, and the first letter represents the row, the second letter is the column. So this is the first row, this is the second row. This is the first column, second column, third column. So this element, number 5, is in the second row, third column. So element A23 has a value of 5. Now, here's another one for you. What's element A12 and also element A21? Go ahead and identify the value of these elements. So element A12, that's in the first row, second column. So that has a value of 7. Element A21 is in the second row, first column, and so that has a value of 6. Let's consider another matrix. So let's say if we have matrix B, and it has the numbers 4, 3, 7, -2, 5, 6, -4, 9, -3, 8, 1, and -7. What is the order of the matrix? So let's start with the rows. This is row 1, row 2, row 3. And then the columns. Column 1, 2, 3, 4. So the order of matrix B, it's a 3 by 4 matrix. It has 3 rows and 4 columns. Now, identify elements B11, B23, B14, and B34. Go ahead and identify these 4 elements. So this one is in the first row, first column. So that has a value of 4. Element B23, that is in the second row, third column. So that has a value of -4. And then element B14 is in the first row, fourth column. So that's equal to -2. And element B34 is in the third row, fourth column. So it has a value of -7. So you need to be able to determine the order of the matrix and the value of every or any element in the matrix. So what I'm going to do at this point is I'm going to give you a list of matrices, and I want you to identify the order of each matrix. So let's say if we have matrix C, and it has the numbers 3, -5, 2, -1. And then we have matrix D, which contains the elements 4, 5, -2, 7, 3, and -6. And then we have matrix E, which contains one number, which is 8. Matrix F, is going to have 7, 4, -5, and 11. And let's say matrix G has the numbers 3, 1, 7, 2, 6, -4, 9, 0, 3. So identify the order of each matrix. Go ahead and try that. Let me just give you one more. Matrix H, which is going to be 2, 1, 7, -3, 6, -2, 5, and 4. And also determine which of these matrices represents a square matrix. So let's start with matrix C. It has 2 rows and it has 2 columns. So therefore, it's a 2 by 2 matrix. Now, this is a square matrix because the number of rows and columns are the same. In a square, all sides are the same. Now, for matrix D, we have 3 rows and 2 columns. So this is going to be considered a 3 by 2 matrix. So the order of the matrix is always going to be the number of rows times the number of columns. Now for matrix E, it has 1 row and 1 column. So because it only has one number, it's a 1 by 1 matrix. Now for H, there are 2 rows and there's 4 columns. So this is a 2 by 4 matrix. And then for F, we have 1 row and there's 4 columns. So that's a 1 by 4 matrix. And finally, the last one, G, that's another square matrix. As we can see, there's 3 rows and it has 3 columns. So that's a 3 by 3 matrix. So now you know how to determine the order of the matrix, and you also know how to identify the elements within a matrix. Now let's focus on adding matrices. So let's say if we have matrix A, and it has the numbers 2, 3, 5, -4. And we have matrix B, which is 7, 4, -3, and 5. What is the sum of matrix A and B? So if we're adding those two matrices, all we need to do is add the corresponding elements. And by the way, if you have a 2 by 2 matrix, you can only add it to another 2 by 2 matrix. The number of rows and columns must be the same when adding matrices, or subtracting matrices as well. So the first element, the one in the first row, first column, we need to add it with element B11 in the first row and the first column. They have to match. So this is going to be 2 plus 7. And then we need to add these two. So in the first row, second column is going to be 3 plus 4. And then we're going to add those two numbers. So that's going to be 5 plus -3. And these two numbers, which are in the second row, second column, the result will remain in that position, second row, second column. Now, 2 plus 7 is 9. 3 plus 4 is 7. 5 plus -3 is 2. -4 plus 5 is 1. So this is the sum of matrix A and B. And that's a simple way to add two matrices together. It's not very complicated. Now let's say if you want to multiply matrix A by 4. What will you get? 4 times A, all you need to do is multiply every element by 4. So it's going to be 4 times 2, 4 times 3, 4 times 5, and 4 times -4. So then 4A is going to equal 8, 12, 20, and negative 16. So what about subtracting two matrices? Let's subtract matrix A and B. So we're going to start with A and then subtract it by B. So it's going to be 2 minus 7, 3 minus 4, 5 minus negative 3, and then negative 4 minus 5. So A minus B, that's going to be 2 minus 7, which is negative 5. 3 minus 4 is negative 1. 5 minus negative 3, or 5 plus 3, that's 8. Negative 4 minus 5 is negative 9. And so that's the difference between the two matrices. And that's it for this video. If you want to find more videos on pre-cal, feel free to check the description section of this video. I'm going to post some links there. So thanks again for watching. In this lesson, we're going to focus on adding and subtracting matrices. So let's say if we have matrix A, it has the numbers 3, negative 4, 8, and 5. And matrix B, which contains the numbers 9, 2, negative 5, and negative 6. What is the sum of matrix A and B? Go ahead and add these two matrices. So we need to add the corresponding elements. Matrix A is a 2 by 2 matrix. It has 2 rows and 2 columns. And the same is true for matrix B. Both of them have the same order. They're both square matrices. And when adding or subtracting matrices, the order must be the same. They have to have the same number of rows and columns. So therefore they have to have the same number of elements. A 2 by 2 matrix has 4 elements in it. So let's add the elements in the first row, first column. So it's going to be 3 plus 9. And then we need to add the 2 elements in the first row and in the second column. That's negative 4 plus negative 5. And then we need to add 8 and 2. And then 5 and negative 6. Now, 3 plus 9 is 12. 8 plus 2 is 10. Negative 4 plus negative 5 is negative 9, and 5 plus negative 6 is negative 1. So that's the sum of matrix A and B. That's the answer. Now let's work on another example. So let's say we have matrix C, which is going to be 7, negative 2, 8, 3, and matrix D, which is 6, negative 1, 5, and 3 as well. So this time let's subtract matrix C by matrix D. So let's subtract the corresponding elements. It's going to be 7 minus 6, and then negative 2 minus negative 1, and then 8 minus 3, 8 minus 5 rather, and then 3 minus 3. So the difference between the two matrices, 7 minus 6 is 1, 8 minus 5 is 3, negative 2 minus negative 1, that's the same as negative 2 plus 1, which is negative 1, and 3 minus 3 is 0. And so that's the difference between matrix C and matrix D. Now let's say if we have matrix A, and we're going to use a 3 by 3 matrix this time. We'll make this a little bigger. So let's say the numbers are 3, 8, negative 5, 4, 6, 2, negative 7, 1, and 3. And matrix B is 4, 3, 7, negative 2, 8, 4, and then 3, negative 5, negative 9. Feel free to pause the video. Go ahead and add the two matrices. So let's write it out first. So we're going to have 3 plus 4, and then 8 plus 3. After that, negative 5 plus 7. In the second row, we're going to have 4 plus 6. Actually, that's 4 plus negative 2. I was looking at this number for some reason. and then it's 6 plus 8, and then 2 plus 4, and then negative 7 plus 3, 1 plus negative 5, and then 3 plus negative 9. So let's go ahead and add those numbers. So the first one, 3 plus 4, that's 7. And then we have 8 plus 3, which is 11, and then negative 5 plus 7, which is 2. And then it's 4 plus negative 2, which is 2. And then 6 plus 8, that's 14. And then 2 plus 4, which is 6. Negative 7 plus 3, that's negative 4. 1 plus negative 5 is negative 4 as well. 3 plus negative 9, negative 6. And so that's the sum of matrix A and B. Let's work on one last example. So let's say we have matrix E, which is 2, 5, negative 9, 4, negative 6, 3, and matrix F, which is 7, 3, negative 6, 5, negative 8, negative 4. Let's subtract matrix E by matrix F. So first is going to be 2 minus 7, and then 5 minus 3, negative 9 minus negative 6, and then 4 minus 5, and then negative 6 minus negative 8, and 3 minus negative 4. So now the difference between E and F, it's going to be 2 minus 7, which is negative 5, 5 minus 3 is 2, negative 9 minus negative 6, or negative 9 plus 6, that's going to be negative 3, 4 minus 5 is negative 1, negative 6 plus 8, that's positive 2, and 3 minus negative 4, which is 3 plus 4, so that's 7. And so that's the difference between matrix E and matrix F. In this video, we're going to focus on a scalar multiplication of matrices. So let's begin with matrix A. Let's say it's 5, negative 2, 7, 3. And matrix B, we're going to say it's negative 4, 6, negative 2, and 9. Now, let's find the values of 3A and 4B. So 3A, all we need to do is multiply matrix A by 3. So every element in this matrix, we're going to multiply it by 3. So 3 times 5 is 15, 3 times negative 2 is negative 6, 3 times 7 is 21, 3 times 3 is 9, and that's it. So for 4B, it's just going to be 4 times all of the elements in matrix B. So 4 times negative 4, that's negative 16, 4 times 6 is 24, 4 times negative 2 is negative 8, 4 times 9 is 36. And that's scalar multiplication. Now, you also need to be familiar with operations associated with matrices that involve scalar multiplication. And we're going to go over some examples relating to that. Now, let's say if we want to find the value of 5A minus 6B. How can we do that? So we got to multiply matrix A by 5. And then there's going to be a subtraction sign, and then we're going to multiply matrix B by 6, or negative 6. If you multiply by 6, the negative sign will remain here. But if you multiply by negative 6, you could change it and put a plus sign, which I think it's easier. So first, let's multiply this matrix by 5. So 5 times 5 is 25. 5 times negative 2 is negative 10. 5 times 7 is 35. 5 times 3 is 15. And then let's put a plus sign and multiply everything in this matrix by negative 6. So negative 6 times negative 4 is positive 24. Negative 6 times 6 is negative 36. Negative 6 times negative 2 is 12. And negative 6 times 9, that's going to be negative 54. So now, all we need to do is add the two matrices. And this will give us the value of 5a minus 6b. So let's add the elements in the first row and in the first column. 25 plus 24, that's 49. And then let's add the elements in the first row, second column. Negative 10 plus negative 36 is negative 46. Now let's move on to second row, first column. 35 plus 12 is 47. And then finally, the second row, second column. 15 plus negative 54 is negative 39. And so that's it for this problem. Now let's try another example. Let's say we have matrix C, and it has the numbers 4, 6, negative 2, 3, 7, 8, and matrix D, 5, negative 2, 3, negative 7, 4, and negative 9. So go ahead and perform this operation. Find a matrix that corresponds to 3C plus 7D. Feel free to try that. So we have 3 times matrix C and then plus 7 times matrix D. Feel free to pause the video if you want to work on this example. So let's multiply matrix C by 3. 3 times 4 is 12. 3 times 6 is 18. And then 3 times negative 2, that's negative 6. And then we're going to have 9, 21, and 24. And then let's multiply every element in matrix D by 7. So 7 times 5 is 35. 7 times negative 2, that's negative 14. 7 times 3 is 21. 7 times negative 7 is negative 49. And then we'll have 28 and negative 63. Now let's add the two matrices to get 3C plus 7D. So first let's add 12 and 35. 12 plus 35 is 47. And then let's add 18 and negative 14, which will give us 4. And then negative 6 plus 21, so that adds up to 15. And then we have 9 and negative 49, which is negative 40. 21 plus 28, that's 49. And then 24 plus negative 63, or 24 minus 63, that's going to be negative 39. And that's it. So now you know how to perform operations with matrices. Thanks for watching. In this video, we're going to focus on multiplying matrices. So let's say if we have matrix A and it has the elements 2, 5, and 6, and matrix B contains the elements 3, 4, and negative 5. So let's find the product of AB and BA. Now, in math, let's say if we multiply 3 times 5 is 15. And 5 times 3 is also 15. When dealing with matrices, the order matters. AB and BA, they will not be the same. So keep that in mind. AB tells us that we need to take matrix A and then multiply it by B in that order. BA tells us that we need to start with matrix B and then multiply it by A. So the order matters. Now, before we begin multiplying, let's talk about the order of each matrix. What is the order of matrix A? Matrix A has one row and 3 columns. So it's a 1 by 3 matrix. The way you write the order is you start with the rows and then you multiply by the columns. So matrix B has 3 rows and only 1 column. So it's a 3 by 1 matrix. So if we multiply A by B, what do you think the order will be? So A times B. So A is a 1 by 3 matrix and B is a 3 by 1 matrix. In order to multiply these two matrices, the columns in the first matrix has to equal the number of rows in the second matrix. So make sure you understand that. And the order of matrix AB is going to be the product of these two numbers, which do not have to be the same. So the order of AB is going to be a 1 by 1 matrix. So therefore, we should have one number in this matrix only. It could be like 7, 12, 15, who knows. But the order of the matrix is basically the product of those two. Now what about B times A? What is the order of that matrix? So we take matrix B and multiply it by matrix A. What should we get? So matrix B is a 3 by 1 matrix, and matrix A is a 1 by 3 matrix. So we have to make sure that the number of columns in the first matrix is equal to the number of rows in the second matrix. So which we do have, so we can multiply these two matrices. Now the order of the matrix is going to be 3 by 3. So the order for matrix BA, it's going to be a 3 by 3 matrix, and for AB we said it's going to be a 1 by 1 matrix. Now let's confirm that. So let's get rid of some stuff. So let's start by multiplying matrix A by matrix B. So the way you do it is you take all the elements in the first row and then multiply it by all the elements in the first column. So it's always going to be row times the column, and then you add the products together. So it's always going to be R times C. So we're going to take this one, it's in the first row, first column, and multiply it by that element in the first row and the first column. So it's going to be 2 times 3. And then we're going to multiply these two. So it's going to be 5 times 4. And then 6 times negative 5. And this will give us only one element. So because we took the elements in the first row and multiplied it by the elements in the first column, we're going to get a single entry in the first row, first column. So it's going to be a 1 by 1 matrix. Now 2 times 3 is 6. 5 times 4 is 20. 6 times negative 5, that's negative 30. And 6 plus 20 is 26. 26 minus 30 is negative 4. So we can see that AB is a 1 by 1 matrix. It has one row and only one column. And so it's equal to negative 4. Now let's multiply B by A. So let's show that it's going to be a 3 by 3 matrix. So we're going to start with B. So remember, it's row by column. So the first row times the first column. So that's going to be 3 times 2. And that entry is going to go in the first row, first column. So 3 times 2 is 6. So now we're still on row 1, but now we have to multiply by column 2. So that's going to be 3 times 5. So it's going to be in the first row, but second column. So that's going to be 15. And then we need to multiply row 1 by column 3. So it's going to be row by column. So 3 times 6 is 18. Next, we're going to move on to row 2 and then column 1. 4 times 2 is 8. So that's going to go in the second row, first column. And then we're going to have row 2 by column 2. So that's 4 times 5, and that's 20. And then it's going to be row 2 times column 3, and 4 times 6 is 24. So hopefully you're seeing the pattern of what we're doing here. If not, feel free to pause the video and rewind until you understand it. And then it's going to be row 3 times column 1. So negative 5 times 2 is negative 10. And then row 3 times column 2. 5 times negative 5 is negative 25. And then row 3 times column 3. 6 times negative 5 is negative 30. So as we could see, AB and BA are clearly different. And you can see that BA has 3 rows and 3 columns. So it's a 3 by 3 matrix. So hopefully this example gave you a good idea of how to multiply matrices. Let's work on another example. So let's say that matrix A contains the elements 1, 4, negative 2, 3, 5, and negative 6. And matrix B contains the elements 5, 2, 8, negative 1, 3, 6, 4, 5, negative 2, 9, 7, and negative 3. So go ahead and multiply A times B and also B times A, and determine the order of these two products. So what is the order of AB? So what do you think the order is going to be? So notice that A has 2 rows and it has 3 columns. So matrix A it's a 2 by 3 matrix. It has 2 rows and 3 columns. Matrix B contains 3 rows and it has 4 columns. So matrix B is a 3 by 4 matrix. So notice that these numbers are the same. The number of columns in matrix A is equal to the number of rows in matrix B. So that means that we are allowed to multiply A by B. These two numbers, they must be the same in order for you to multiply the two matrices. Now the order of matrix AB is going to be 2 times 4, or 2 by 4. So it's going to have 2 rows and 4 columns. Now what about B times A? What can we say about that? So matrix B has 3 rows and 4 columns, and matrix A has 2 rows and 3 columns. So notice that these two numbers do not match. They're different. And in order to multiply B times A, they must be the same. So therefore, BA does not exist. We don't have to worry about that problem. So let's focus on multiplying A by B. So it's going to have 2 rows and 4 columns. So let's start by multiplying row 1 by column 1. So it's going to be 1 times 5, and then it's going to be plus 4 times 3, and then plus negative 2 times negative 2. So you got to multiply these two first, and then these two together, and then those two. It might be wise for me to perform the operation somewhere else. So let me get rid of this. I'm going to put the answers there. So it's going to be 1 times 5 plus 4 times 3 plus negative 2 times negative 2. So this is going to be 5 plus 12 plus 4. 5 plus 12 is 17. 17 plus 4 is 21. So because we multiplied row 1 by column 1, we need to put this answer in row 1, column 1. So this is row 1, row 2, and this is going to be column 1, 2, 3, and 4. Now let's multiply row 1 by column 2, and that will produce an entry in row 1, column 2. So first, we need to take 1 and then multiply it by 2. And then it's going to be 4 times 6, and then negative 2 times 9. So 1 times 2 is 2, 4 times 6 is 24, negative 2 times 9 is negative 18. So 2 plus 24 is 26, 26 minus 18 is 8. So let's place that entry in that slot. Now let's move on to row 1, column 3. And that's going to be an entry in row 1, column 3. So we're going to multiply 1 by 8. And then 4 by 4. And then negative 2 times 7. Or you can write it as plus negative 2 times 7. So 1 times 8 is 8, 4 times 4 is 16, negative 2 times 7 is negative 14. Now 16 minus 14 is 2. 8 plus 2 is 10. So we get that answer. Now let's move on to the first row, 4th column, which will produce an entry in row 1, column 4. So it's going to be 1 times negative 1 plus 4 times 5 plus negative 2 times negative 3. So this is going to be negative 1. 4 times 5 is 20. Negative 2 times negative 3 is plus 6. So 20 plus 6 is 26. And 26 minus 1 is 25. So hopefully by now you get the hang of it. If not, feel free to rewind the video. So let's move a little faster. So row 2 times column 1. That's going to be 3 times 5 plus 5 times 3 plus negative 6 times negative 2. So that's 15 plus 15 plus 12. 15 and 15 is 30. 30 plus 12 is 42. So we need to put that there. Next, we have row 2 times column 2. So that's going to be 3 times 2 plus 5 times 6 plus negative 6 times 9. 3 and 2 is 6. 5 times 6 is 30. Negative 6 times 9 is negative 54. Now 30 minus 54 is negative 24. And 6 minus 24 is negative 18. Now let's move on to row 2 times column 3. So it's going to be 3 times 8 plus 5 times 4 plus negative 6 times 7. So 3 times 8 is 24, 5 times 4 is 20, negative 6 times 7 is negative 42. 24 plus 20 is 44, and 44 minus 42 is 2. Now for the last entry, we're going to multiply row 2 by column 4. So that's going to be 3 times negative 1 plus 5 times 5 plus negative 6 times negative 3. So this is negative 3. 5 times 5 is 25, and negative 6 times negative 3 is 18. Now negative 3 plus 25 is 22. 22 plus 18 is 40. And so now you know how to multiply two matrices together. And as you can see, we did get the 2 by 4 matrix as predicted. So if you multiply a 2 by 3 matrix with a 3 by 4 matrix, first you must see that these two are the same, and then the order of the new matrix is going to be the number of rows of the first matrix times the columns of the second, which we have here. It's 2 rows and 4 columns.